So in this question, what we want you to do is to use the picture you've been given in the haemocytometer to work out the density of cells in your original suspension. So for this example calculation, I'm just going to calculate this based on this square alone. We're asking you for an average, but we're going to do it for this square alone. So we can see if we use the rules for counting haemocytometer, then we shouldn't count that cell, but we can count the other two cells. So those, we've got two cells in the square. Okay, so we now need to work out what size of square that is. So if we look at, if we compare the zoomed in image on the microscope to the whole haemocytometer, then what we're looking at zoomed in is this bit just here. Okay, that's where we were at. So we can use the lines that we've got to work out where we are on the haemocytometer. So each one of those little squares is in fact the same as our little purple square in there. So the sides of this square in the previous question you've already worked out that is 0.05 millimeters. So we can use that to work out the volume, which I'm not going to go through that because there's another video about that. So if we work out that volume, we should get to a volume of 0.25 nanoliters. Okay, so we've got at the moment our density is 2 cells in 0.25 nanoliters. Okay, so that's not a particularly helpful measurement. So what we can do is to then work up. So we can say, well, if we've got 2 cells in 0.25 nanoliters, then therefore we would have 8 in 1 nanoliter. Okay, that's fairly straightforward. Okay, so we know that 1 mil equals 10 to the 6 nanoliters. Okay, so therefore we must have 8 times 10 to the 6 cells per milliliter. Okay, so if we first of all work out the cells in 1 nanoliter, then we can use that volume conversion there to get to our final answer. Don't forget that the Canvas question is asking you just for this number here. Okay, so it doesn't want, we're already giving you the 10 to the 6, we want you to put that number in there. So in my case that answer would be 8, but as I say, we've asked you to calculate an average cell density, not just from one single cell.